Hello everybody, today we're going to solve rational equations. Alright, we're going to solve the rational equations by using the LCD, and we're going to check for extraneous solutions. Alright, this is set up just as a proportion, so we're just going to solve this just as you would a proportion. We're not going to use LCDs on this guy. Okay, so we're going to multiply these terms. Okay, now finish this out, see what you get for an answer, then check your solutions. Alright, you solved the problem, found x equals -2, plug it back in, and what you want to do is you want to make sure you're not dividing by 0 where you don't have any imaginary numbers in there. Okay, and that these both work out to be the same answer, -3 and -3, so this is a good solution. Alright, problem number 2. Why don't you guys start and check your answer at the end. Okay, got x is 16. Plug it in, 1/2 and 1/2. Good solution. Problem number 3. Okay, here is where we're going to have to find the LCD. Remember how we find the LCM. The LCM is the LCD. It's each factor that occurs and the most amount of times it occurs in any one term. This is one term, that's another term, that's a third term. So my LCM is going to be x and 4. Okay, so what we're going to do is we are going to multiply each of these terms times the LCM. And what that is going to do is that is going to add the rational expressions on the left, okay, and get it to a point where it's a proportion, and then do the cross multiplication for us. It's going to eliminate a couple of steps. In the interest of time, here's what it looks like. So the LCM times the first term, LCM times the second term, LCM times the third term. Okay, these cancel. 5 times 4 is 20. The 4's cancel. 7 times x is 7x equals, the x cancels with this. -9 times 4 is -36. Finish it out. X is equal to -8. I would put a -8 in here. 5 divided by -8, that's not a 0 on the bottom, so that's good. 7/4. -9 over -8 is 9/8. Okay, now I'm not going to solve it all out to see if this works. I just know it's not going to be a 0 on the bottom, so in the interest of time, this is a good solution. Okay, you should check your answers and add the fractions. Now, this is a little tedious, writing it out 3 times. So I have a quicker way of doing it. What we do is this. We write the LCM one time on the outside, and you're basically just put parentheses around this. And just got to remember to distribute this in. So in this first term, the x's would cancel. Second term, the 4's would cancel. And the third term, the x's would cancel. You'd end up at the same spot. Problem 4. First thing we want to do is find the LCM. So the LCM, remember this is one term. Okay, this is one term. So my LCM is going to be x times x minus 5. You can put the x minus 5 in front of the x. It doesn't make a difference. Okay, so we're going to multiply each of these terms, that's one term, 2 terms, 3 terms, by the LCM. Here's what it looks like if you lay it all out. Okay, each term gets multiplied by the LCM. So we want to do this first. This is going to be x squared minus 5x. Okay, this bottom is going to cancel with this, so that's x times negative 8. Bring down the equal sign. This cancels with this, so it's 3 times parentheses x minus 5, which is 3x minus 15. Okay, solve this, factor it, tell me what you get for an answer. Okay, so for this problem here, I got x equals 15, or x can equal 1. If I plug the 1 in here, I get 1 minus 5, which is negative 4, so I can divide by negative 4, so I'm good. Put a 1 in here, 3 divided by 1, I'm good. Put a 15 in here, or 15 in there, and I have good numbers. I'm not dividing by 0, and I have no imaginary numbers. I did the math on a separate sheet of paper, and they are good answers. Now, another way you could lay this one out is like this. It just basically is doing the same thing. You're just distributing this into the 1, distributing this into this term, distributing this into the final term. Okay? Why don't you guys do this problem, see how you make out, and then come back and check your answer. Alright, I got x is equal to negative 10. If I plug negative 10 up here, and I add all those fractions up, I'm going to get a good answer. Both sides are equal. So x equals negative 10. Number 6, you know what to do. Give it a shot and come back and check your answer. Okay, so I solved this problem. Alright, I just tried to show you what I was canceling out there and multiplying. X equals 21. If I plug 21 up in here, I have a number that's not 0. That's good. If I put negative 4 over here, I got a number that's not 0, so that's good. I did the math. These work out to be good answers. So x equals 21, or x is equal to negative 4. Alright, problem number 7. Alright, you know what to do. Give it a shot. Alright, glad you're back. Got two solutions here. Try to do a little color coding here. The pink crosses that pink out, and you multiply the 6 times the first term. Both of these terms cross out, you just bring down the 8x squared. Cross out the x plus 3, multiply 4x times x minus 3. Hope you can follow along with that. Did all of this. Now check your answers. If I put this negative 3 right up here, that would be negative 3 plus 3, which is 0. I'm not allowed to divide by 0. So this does not work. This is extraneous. So my only solution for this one is x equals 3 halves. Alright, problem number 8. You know what to do. And come back and check your answer. Alright, glad you're back. So I got x equals negative 3/5, x is equal to 2. I tried both those answers up here. They both work, good answers. So I have two answers here. One little trick I did right here is if the first number is a negative, divide everything by negative 1, flips the signs around, makes it easier to factor when that first number is a positive. Okay? Still going to give you the same answers. Alright, just a nice little trick. So I hope you enjoyed this video, and I'll see you on the next video.